All right, so on to chapter 3. We are dealing with derivatives again. We're going to talk about in chapter 3, section 1, increasing, decreasing, min, max, how they relate to each other, maybe some applications towards the end. But I was just going to look at a couple of these. Evaluate the derivative of the function and indicate points on the graph. So specific points. Where solutions are at, where min or max are located at. Those are always good points of information. In the book we call these critical points. So whenever your first derivative is set equal to 0, you can find critical points. So looking at this, here's this function, and this, if we were deriving it, we would be doing the product rule. I'll make a supplement with doing that. But just graphically, if I get this equation in here, let's try that again. It's x plus 1. And so we get this exact same picture that they had. We could zoom in on it a little bit. And so we get that picture, right? Notice that it only begins at -1 and then goes over, just because that's not in anything to the left of -1 is not in our domain of our function. So this is our function. We could graph the derivative if we wanted to. See if that gave us any insight. So again, the derivative is just talking about the slope. Well, this purple line, once we get to this point right here, this -2/3, our slope is a positive value, which means it's increasing. Once we get to 2/3, our slope starts to decrease. Again, because this purple line represents our slopes. These are negative numbers, these are positive numbers. So if we look at the green graph, we see that it has a maximum at that -2/3, and then it starts decreasing. So exactly what the purple line tells us. We have positive slope values until we get to 2/3, and then we have negative slope values. So that's kind of interesting that we can look at the graph, help determine where the min and max are located. Again, those critical numbers are when you take the first derivative and set it equal to 0. So I'll do a supplement on how to find that first derivative of this function and solve for it algebraically. Another one from this section I want to look at was number 5, a little bit more word problem. Make sure with these, just making sure you're getting your intervals correct, decreasing, increasing, where they're doing that. So on here we have the profit P made by a cinema from selling X bags of popcorn can be modeled by this thing. Find the intervals in which the function is increasing and decreasing. So to do that, we would take the first derivative and set it equal to 0, and then solve for that. These will give you the critical points, and somewhere around those critical points, we will be able to find where they're increasing and decreasing. We also can graph this equation, and if we graph it, we'll see that we get this nice picture of what's going on. What we got next? Minus x squared divided by 24,000 minus 3,100. And so sometimes the hardest part with graphing something is finding where the equation is, right? So here's my equation. Well, I know when I plug in 0, I get -31,000, so it's way down low. So, and we're talking about our x, so that's number of bags of popcorn. So I'm guessing in the world of popcorn, we could probably make a lot of popcorn. So I'm going to have my x go from, let's go 0 to 1,000 bags of popcorn. And then my y, kind of need that to fit somehow. I know that if I plugged in 0, I would get negative 3,100. Oh, and I start seeing my line. Good. And then maybe I could see how high it would go. Let's try like 10,000. That sounds like good money. But if I do that, notice that this isn't far enough out. So we really kind of have to play with our bounds. I'm going to make this one be 5,000 bags. So we get this idea of this equation, what it looks like. We do have something that's, somewhat parabolic, right? It just isn't growing very fast. It has this 1 over 24,000. But we could find slopes at different points. And that's what we're asked to do in the problem, or when is it increasing, when is it decreasing. I bet if we go out far enough, we'll find this thing actually starts decreasing since I know it's a negative quadratic. Let's go to 25,000 bags of popcorn. That's 250. That's a lot of popcorn. It looks like I could probably narrow it down to about 75,000. So when you're graphing it, you kind of have to just play around with it. Let's ump our profit maybe up to 25,000. And so we're starting to see it. And it does have a max, right? So this is the place where my function is increasing and then it goes to decreasing. The slope of my tangent line is equal to 0. If I take my derivative and set it equal to 0, I should get this 27,840 number. So getting a good graph of the picture doesn't hurt, especially if you're trying to find where our function is increasing. Well, obviously we can see that it's going up until it gets to there, and then it starts decreasing. When we take the derivative of this equation, we'd find, let's do that. We will see, oh, there's that black line all the way down low. Let's go, at that point, it goes from negative values to, see, look at that y value, it's negative. See, it's going down, but up here, we have positive values. Right? So our slope is increasing, so it's still going up because it's positive. But once I hit this number right there,